Alright, so for every example that we're doing in the right angle trigonometry unit, you are going to be drawing a right triangle, okay? This is also something that will be part of your quiz points, like it'll say make sure you draw a picture for full credit. Does not have to be to scale, it just has to include a picture. Okay, so I want you to draw a right angle triangle, okay? Again, does not have to be to scale. So in this competition, this water skiing competition, a jump ramp is 19 feet long from the water to the top of the ramp. Okay, so the ramp is 19 feet long from the water to the top of the ramp. Okay, so then we know that the angle between the ramp and the water is 15.1 degrees. We have to find what is the height to the nearest foot above the water that a skier leaves the ramp. Okay, so now that I have more context, okay, I'm going to put my water in there. Water is optional. Okay, and then I have my water skier, so here's my water skier person, and then this is the ramp. Okay, so where should I be putting the 19? Yes, the hypotenuse. This is how far they are. Think about where the water skier's going, right? They're going up the ramp and then, woo! So we are going to find the angle between the ramp and the water, okay, which is going to be right here. So 15.1 degrees. And then it says we have to find the height to the nearest foot above the water that a skier leaves the ramp. Okay, so where would the height go?
X.
Yep, you can call it X, but where to go? At the base or here? Yes. Okay, I'm going to call this H for the height. Again, you can call it X or any other variable that seems right to you. And then we're going to do this the same way that we did part C above. So this is going to be the opposite side from my angle. This is going to be the hypotenuse because it's across from the right angle. So the opposite and the hypotenuse is the sine function. That's how I decide whether I'm using my sine, my cosine, or my tangent. Okay? Whenever you're doing the sine, it's always of the angle. And then this would be the opposite over the hypotenuse. And then because my variable's on top, what am I going to end up doing with these two values? Multiplying. Good. So 19 times the sine of 15.1 degrees. Okay, so again, anytime you clear your calculator, it does reset it back to radians. So make sure that you double check just every time you reset it. So not just the clear, but like if you do set the second plus 712. Yeah. Not every time you just do that. Okay, so then this is about 4.9 ... It says to round to the nearest foot, so the height is about 5 feet. Okay, now when you get to the end, make sure you also label your units. So in this case, if they give you the units of measurement, you use those as well. Okay? Alright, for the next one we have a biologist whose eye level is 6 feet above the ground. And it measures that angle of elevation to the top of the tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, okay, we have to find what is the height of the tree to the nearest foot. So again, I just recommend that you always start with your triangle, okay? And the scale isn't super important to me, okay, as long as you have your right triangle, and then this is their eye level. I'm just going to draw my person. Okay, so this is the biologist, and then it talks about their eye level. So from here to here is going to be 6 feet. Okay, so 6 feet, their eye level is above the ground. Okay, and then it says the angle of elevation to the top of the tree is 38.7. So angle of elevation is something you did in geometry. So elevation starts at the horizontal and goes up. So this would be your 38.7 degrees. Okay, and then this was to the top of the tree, so I just made a little tree here. Yeah, and this is, again, this is obviously not going to be drawn to scale because I have because it tells me that the biologist is standing 180 feet from the tree's base. So from here to the tree's base, yeah, the bottom would be 180 feet. Okay, so obviously that's not the scale based on what I have. Okay, I know the tree looks pretty good for you guys. All right, so now again, what we're trying to find is the height of the tree. So we're trying to find this entire height, but we already know that from here to here, the height is 6 feet. What we're gonna find is this height using our triangle, okay? So whatever we get for x, we are gonna have to add that to the 6 feet. Okay, so here we have the opposite and the adjacent. So if we have O and A, what function are we gonna use? Yep, the tangent. So the tangent of what? Yes, 38.7 degrees equals x over 180. Okay, so we're going to multiply or divide on this one? Yes. Anytime variable's on top, you multiply. And remember, we're rounding to the nearest foot. Okay, so approximately, what do you get for x? 144. Good, 144. And then your final thing is just going to be to add your 6 feet. So 150 feet is going to be the height of the tree. All right, and then your homework is on your calendar.